All right, we have one last concept to look at in section 1.2, and that's the idea of when is a function increasing and when is it decreasing. So if our function is y is equal to f of x, we're going to look at when it's increasing and decreasing in several different scenarios. So if we're looking at the values of y, I'll put a little sketch up here. Okay, so over this interval, we would say it's increasing here because these y values are getting bigger. Okay? So what I'm going to put in this box is my y values either increase or get bigger from x equals a to x equals b. And it has to do that all the way along that whole interval. So it is increasing here, but then it starts decreasing and then it's increasing again. So it needs to be increasing over the entire interval. So we would say it's increasing from here to here and then from here to here. But this part in the middle we would say is decreasing. So the values of y over that interval from a to b are decreasing or getting smaller as we move from x equals a to x equals b. The graph, and we always read our graphs from left to right, and we have some examples down at the bottom of the page, and I'll be sure to point out why I'm making a big deal about saying that we're going to read our graph from left to right. So the graph, our picture here, is going to rise or grow or increase when we read our graph from left to right. Okay, so that's kind of this uphill look. And then it's going to fall when our graph is read from left to right. Okay, so that would look like this. And if your function is increasing over an interval, that average rate of change for that interval is going to be positive. And if it's decreasing, then our average rate of change is going to be negative. All right, so let's take a look at some examples here. So we're going to figure out where these functions are increasing and decreasing. So we read these from left to right. And so the reason I want to point this out is that we have these arrows on the end here. And what people have a tendency to do is they see the arrow and so they look at this and they think, oh, it's shooting up to infinity over here. This looks like it's increasing. But the problem is we read this graph from right to left because we're looking at it going this way and our x values going this way. We need to look at it with our x values going this way. So you always start on the furthest edge of your function and you see what it's doing as you follow it along. So if I'm following it always from left to right. This guy is decreasing here. So it looks like it's decreasing from here to here, and it's increasing from here to here, and it just keeps going, going, going. Okay. All right, so the way we're going to write this is that it's increasing. It starts increasing when x is equal to -1. So kind of shorthand, you could say it's increasing from x is equal to -1 all the way to infinity. We're going to write that in interval notation. So that looks like this. We'll put a -1 and a comma, and we'll put the infinity symbol. Looks like that. And then it's decreasing. So it'll start decreasing. On this edge of our graph, we would call this negative infinity. It's going to decrease from negative infinity, and it's just coming down, 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 until we get to x equals -1, and then it's going to turn around. So our decreasing interval is negative infinity to -1. All right, let's look at the second picture. So we're looking for it's increasing and decreasing. And a good way to do that is to mark out the high point and the low point. And there could be multiple ones in a graph, but you'll mark out kind of all of the mountaintops and all of the valleys. And this piece here in the middle, so from this mountaintop to this valley, okay, we have decreasing. And then from the bottom of this valley, the rest of the way here is going up, up, up. So it's increasing over here. The last part is to come back to the start of the graph and figure out what's going on at the beginning. we start at the arrowhead of the function, and we follow it along. So we're reading it as x goes from left to right. We're looking at what the y values do as we read x from left to right. So this is going up, up, up to reach this mountaintop. So it is increasing over here. So we have an increasing, a decreasing, and another increasing interval. So this increasing interval starts at negative infinity. And we know that with this arrowhead here, it's just going to keep going, going, going. So that's where I'm getting that negative infinity from. And it looks like it's going to go until about 1, 2, 3. So maybe, I don't know if that's a 3 or a negative 2.5, somewhere in there. That's either one of those answers would be fine. I'm not, either I will give you, on the test, I'll give you a graph that's really clear, like this one was, where it falls. Otherwise, I do kind of take that with a grain of salt. And if it looks like you made a really good faith attempt and you're kind of in the right ballpark, you're fine. So anything like negative infinity to negative 3 or negative infinity to negative 2.5, somewhere in there is fine. And then this next piece, we'll pick up where we left off. So we'll call that negative 3 to 0 is in the decreasing. And then we start again at 0, and this one's in the increasing group. It's going up, 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 so 0 to infinity. So I have 2 intervals increasing, 1 interval decreasing. And then this last graph, so it certainly looks like if I start on the left edge of my function with this arrowhead, increasing slowly, wow, increasing super fast, and then kind of levels off. So it is pretty much increasing over this whole interval. This is getting pretty steep in here, but I don't see any place where it's decreasing. So we'd say it's increasing from negative infinity to positive infinity. Or there's another way of representing that. If it's doing the same thing over that whole interval, we would say that that's all real numbers. And we shortcut, because mathematicians have symbols for everything. We shortcut the words all real numbers with a capital letter R that has kind of that double-edged back to it. So it's got those 2 lines there. And then it's not decreasing at all. So if you have something that function that isn't increasing or decreasing, make some sort of mark, or at least put an NA or not decreasing or something like that, so that I know that you understand that there is no place where it's decreasing and it wasn't like you left that answer blank because you forgot to answer it or something like that. All right, so hopefully that kind of makes some sense. I think we all have a pretty good idea looking at a picture what increasing and decreasing is, but hopefully this makes some sense putting some words to it. And that's pretty much the last concept for 1.2, so I will see you back in the videos for section 1.3.